I'm here with Dr. Rebecca Hahn, and we were talking about the tricuspid interventions. I think the images in interventions are crucial for the success of the procedure and even for patient selection. How do you think we can improve our success in the future?
Yeah, I think that there are so many different advances that are happening now for imaging, and it's all based on the structural field.
Yeah.
So it's that the need was so great in structural imaging for procedural, not only screening and diagnosis, but also for guidance. And so there's so many different advances in imaging. One of them is computational modeling. So we know that we can, for TAVR, as well as now hopefully in the future for mitral clip or even tricuspid, be able to use CT scans or sometimes three-dimensional echo to model what will happen when we put a device in.
Yeah.
And so this will be...
we can preview the results.
Exactly. And that may help us with device choice. Because now, for instance, for the aortic valve, we have so many different devices. They may give us different gradients. This modeling can actually predict the gradient that we might get with each different device. So I think that that's a big advance. One of the other advances that I'm really excited about is the artificial intelligence driven guidance. So we now have already in Europe approved a software package that is able to image or see the device and the TEE echo probe on the fluoroscopic screen. And then it can automatically, because it understands what the volume of imaging will be, it can then reformat the imaging automatically to image the device and never lose track of the device.
Yeah.
So as the device is moving, the images change. This is going to really democratize a difficult procedure such as the TEER devices, the edge-to-edge repair devices. So I think that's a really large advance. And then there are other things that are also going on with automated quantification tools, and these are also AI-based, as well as robotics. So I think that the future is
radiation.
So for us, we're really right next to the radiation source, and the imager is really in danger.
It's always a problem.
Always a problem. And so if we have a robotic control of our probe, and it has haptics so that we can feel the pressure and understand how not to injure the patient, we might be able to step out of the radiation field and be in the control room or be 6 feet away from the patient and really reduce our radiation exposure while not affecting the guidance of the procedure and the efficacy of our devices. So it's just an exciting field. It's such a fast-moving field, and that's because structural is such a powerful force now in the management of our patients.
Fascinating. Thank you, doctor. It's such a pleasure to have you here.
Thank you so much for having me.